Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture, we are going to cover the topics functional dependence of functions of several variables. Let us see the definition of this functional dependence. See, if u comma v are functions of two variables x comma y and u comma v are said to be functionally dependent, then the Jacobian vanishes. That is, Jacobian of u comma v with respect to x comma y will be 0. If the Jacobian of two functions is 0, then we say that those two functions u comma v are functionally dependent. There is a note: if Jacobian of u comma v is not equal to 0, then we say that those two functions are functionally independent. Right. Let us see one problem. U is equal to x plus y by x1 minus xy and v is equal to tan inverse x plus tan inverse y. So u and v are two functions of variables x and y. So is asking to find the Jacobian of u comma v with respect to x comma y. Hence prove that u comma v are functionally dependent, and if so, what is the relation between those two functions u and v that we have to find. First, let us prove that the Jacobian 0. So Jacobian of u comma v with respect to x comma y, how we denote this Jacobian? That is dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So find the determinant of all these partial derivatives. We'll be getting the concerned Jacobian. So first of all, let us find these partial derivatives dou u by dou x. So u is given as x plus y by 1 minus xy. So you want dou u by dou x. So let us apply u by v rule. So 1 minus xy into derivative of x plus y is 1 minus x plus y into derivative of 1 minus xy with respect to x, that is minus y divided by 1 minus xy whole square. So this is 1 minus xy minus into minus plus xy square plus y square divided by 1 minus xy whole square. This is dou u by dou x, right? Next, coming to dou u by dou y. So again apply u by v rule. 1 minus xy into derivative of x plus y with respect to y is 1 minus x plus y into derivative of 1 minus xy, that is minus x divided by 1 minus xy whole square. So this gives 1 minus xy plus x square plus xy divided by 1 minus xy whole square. So minus xy plus xy cancel, that gives 1 plus x square by 1 minus xy whole square. This is also xy. So this is 1 plus y square by 1 minus xy whole square. So we got dou u by dou x, dou u by dou y. Next, let us find dou v by dou x, dou v by dou y. So what is v here? Tan inverse x plus tan inverse y. So dou v by dou x, tan inverse x derivative 1 by 1 plus x square, and dou v by dou y, that is 1 by 1 plus y square. So therefore Jacobian of u comma v with respect to x comma y is, what is dou u by dou x? 1 plus y square by 1 minus xy whole square. Next, 1 plus x square, 1 plus x square by 1 minus xy whole square. Next 1 by 1 plus x square, 1 by 1 plus y square. So if you find this Jacobian, this will be 0. That means u and v are functionally dependent, means one function is depending on another, functionally dependent. If these two are functionally dependent, therefore we can find the relation between these two functions. Let us see. We can observe u is equal to x plus y by 1 minus xy and v equal to tan inverse x plus tan inverse y. If we observe this function v, we can have the formula in trigonometry tan inverse a plus tan inverse b, right? So v is equal to tan inverse x plus tan inverse y. This can be written as tan inverse of x plus y by 1 minus xy. So this can be written as tan inverse of, what is x plus y by 1 minus xy? That is u. We can write this as u. Therefore the relation between u and v is equal to tan inverse u. This is the relation, right? Let us see one more problem. U is equal to xy plus yz plus zx is one function of xyz. V is equal to x square plus y square plus z square and w equal to x plus y plus z. So all the three functions u, v, w are functions of x, y, z. Is asking to show that these three functions are functionally dependent and also find the relation between them. So first let us find the Jacobian. Let us see we get that Jacobian 0 or not. So if there are three functions u, v, w, in that case how will you represent the Jacobian? Let us see. So Jacobian of three functions u, v, w with respect to three variables x, y, z, that is given as determinant of dou u by dou x, dou u by dou y, dou u by dou z. Next dou v by dou x, dou v by dou y, dou v by dou z, dou w by dou x, dou w by dou y, dou w by dou z. So all the partial derivatives with respect to x, y, z, derivative of u with respect to x, derivative of u with respect to y, derivative of u with respect to z. We can also represent this as u suffix x, u suffix y, u suffix z. Next coming to second row, dou v by dou x can be written as v suffix x, dou v by dou y means v suffix y, v suffix z, dou w by dou x, dou w by dou y and w suffix z means dou w by dou z. We can also represent like this. First let us find all these partial derivatives and substitute in this. We have to get the Jacobian 0. So what is dou u by dou x? With respect to x we are differentiating, so we get y plus z. Dou u by dou y means z plus x. Dou u by dou z, that means we get x plus y. Next coming to dou v by dou x. So x square derivative 2x, next plus y square is 0, z square is 0. So we get dou v by dou y with respect to y derivative 2y, dou v by dou z. If you differentiate this with respect to z, we get 2z. Next dou w by dou x, w is given as x plus y plus z. So x derivative 1, here y derivative 1, z derivative 1. So let us expand this determinant and let us see whether we get 0 or not. So this is equal to y plus z into this into this minus this into this, 2y minus 2z minus z plus x into 2x minus 2z plus x plus y into 2x minus 2y. So let us multiply each and every term. This is 2y square plus 2yz minus 2yz plus 2z square, sorry, minus 2z square. Similarly, zx into 2, z into 2x is 2xz. So let us write in next page 2y square plus 2yz, 2y square plus 2yz minus 2yz minus 2z square minus 2yz minus 2z square minus z into 2x, 2xz minus 2xz minus z into z, 2z square minus 2z square. Next, x into 2x is 2x square, that is plus 2x square. X into 2z is 2zx, right? Next, plus x into 2x is 2x square plus 2x square. X into minus 2y is minus 2xy. Y into 2x is 2xy. Y into minus 2y is minus 2y square. So Jacobian of UVW with respect to x, y and z, that is, so if I remove this bracket, minus plus minus plus, so minus 2yz plus 2yz cancel, minus 2xz plus 2xz cancel, minus 2xy plus 2xy cancel, minus 2y square plus 2y square plus 2z square minus 2z square plus 2x square minus 2x square cancel. All the terms are get cancelled, we get 0. Since the Jacobian of UVW is 0, what can we say? The functions u, v and w are functionally dependent. Functionally dependent. Now when the functions are dependent on each other, there should be some relation between these three functions u, v, w. Let us see what is w here. If we can observe, x plus y plus z is the function. So if we can consider w square, that means x plus y plus z whole square. We can write this formula as expand this x square plus y square plus z square plus 2xy plus 2yz plus 2zx. So this implies w square is equal to x square plus y square plus z square plus, in all the three terms we can take it to common, xy plus yz plus zx. Now we can observe x square plus y square plus z square is v. So this I can write it as v, and xy plus yz plus zx can be written as u. Therefore w square equal to v plus 2 times of u. So this is the relation between three functions u, v and w, right? Let us prove one more problem. Prove that u is equal to 2x minus y plus 3z, v is equal to 2x minus y minus z, w equal to 2x minus y plus z are functionally dependent. And if it is functionally dependent, we have to find the relation between those functions. Again, there are u, v, w are functions of three variables x, y, z, as we have done in the last problem. Jacobian of u, v, w with respect to x, y, z This can be written as ux, uy, uz, vx, vy, vz, wx, wy, wz. What is dou u by dou x? 2. Dou u by dou y, that is -1. Dou u by dou z, 3. Next, dou v by dou x is 2. Dou v by dou y is -1. Dou v by dou z is -1. Next, coming to dou w by dou x, that is 2. Dou w by dou y, with respect to y, if we differentiate, we get -1, and last +1. So this is equal to 2 into -1 -1 minus of minus plus 1 into 2 plus 2 plus 3 into -2 plus 2. So this is -1 is -2 into 2, -4 plus 4 plus 0. So I get 0. So Jacobian of UVW is 0. Therefore, what can we conclude? The functions UVW are functionally dependent. If these functions are functionally dependent, there should be some relation between these three functions u, v, w, right? Let us see this. So first consider, by observing the given functions u, v, w, we can find the relation between them. What is the function? U equal to 2x minus y plus 3z, and v equal to 2x minus y minus z, w equal to 2x minus y plus z. So if we observe u plus v minus 2w, so u means what? 2x minus y plus 3z minus y plus 3z plus v means what? 2x minus y minus z, 2x minus y minus z, minus 2 into w means 2x minus y plus z. So this is 2x minus y plus 3z plus 2x minus y minus z minus 4x plus 2y minus 2z. So this is 2x plus 2x, 4x, minus 4x get cancelled. Next, minus y minus 2y and plus 2y cancel. Similarly, minus 3z plus 3z cancel, we get 0. Therefore, u plus v minus 2w equal to 0. This is the relation between the given three functions u, v, w. This is how we show that the given functions are functionally dependent, and this is how we find the relation between them. So till now we have seen the functionally dependent and how to find the relation between them. Thank you.